Right, next up, number 4. Well, half of number 4. The next half is coordinate geometry. Those normally make up the whole of number 4. And functions are easy one to get marks from. Has some algebra in it, but it's basic algebra, just substitution most of the time. And if you remember the rules, it could be a lot easier. So this is the function. F at x is 2x plus 7 over 5. And I want f at 4 plus f at minus 4. So f at 4 means in the f function, is when you have one function. I going to replace x with 4. So wherever I see x, I'm going to put 4. So f at 4, wherever I see x, instead of having 2 by x, I have 2 by 4 plus 7 all over 5. 2 4s are 8, 8 at 7, 15 over 5, which is 3. That part finish, right? Same idea here now. F at minus 4, well, I replacing x with minus 4 now. And again, you have to be careful with your negative numbers. This is 2 times minus 4. I put it in brackets, but really mean multiply when the letters close to the numbers. 4 2s are 8, so 2 times minus 4 going to be minus 8 plus 7. Minus 1 over 5, so it's just 1 over 5. So I really have now 3 for f at 4 minus 1/5. And by now you should know to work this out. You can find the LCM, whatever, it's going to work out to 2 and 4/5 from a 2 marks. That's an easy 2 marks to get. Let me see what some of the other function pieces would look like. So here now they want the value of x for which f at x equal 9. So we just find out f at x was 2x plus 7 over 5. And now they tell me this equal to 9. So I really have 2x plus 7 over 5 is equal to 9, because that's what f at x is. F at x is 2x plus 7 over 5. That's what they just tell me. And now they tell me that equal to 9. So they want me to solve it. So to solve anything, it's now it's easier to not have fractions. So to get rid of fractions, I'm going to cross multiply. So I'll put in this side as a fraction, this side already a fraction. I will multiply going this way and this way. So 1 times 2x plus 7, 1 times anything is the exact same thing. No need to work it out. 5 times 9, 45, because I multiply 5 by 9, right? That's how I get the 45. And now this is easy to solve. You realize once I cross multiply, if I had fractions on both sides, once I have fraction on one side of the equal sign, if it's a whole number, I'll put it over 1 to make it a fraction on the next side. Once I cross multiply, no more fractions, and look how easy this is to solve. Because I might know you have to know how to solve as well. Letters on one side, numbers on the next. So he's a number. So he needs to move to this side. And when I'm moving something, the sign is changed. So plus 7 going to change to minus 7. So 45 minus 7 is 38. So I have two things cost $38. So one of them will be 38 over 2, which is, 19. And that's it. 2 extra marks. Next one. They want f inverse 9. So the inverse is the hardest part of functions. And just to go over how to get the inverse, you can do it in your head by just shifting across stuff, or we're going to do it the long way. So the function is f at x equal 2x plus 7 over 5. That's what I want to find the inverse of. I can't use f at x and x to make it a little harder. So I'm going to replace f at x with y and x. And then the key part is to switch x and y. Again, we do all this already. You can look back at those videos. I kind of teach it back. The video is there online. You need to check it up, right? So I'm going to switch x and y. So wherever I see y, I put x. Wherever I see x, I put y. And now I want to solve for y. And just like before, just like in this last one, I have fractions on both sides. So I'm going to cross multiply. So this is going to multiply by this. This is going to multiply by this. I'm continuing it on top here. So when I cross multiply, I get in 5 by x, which is 5x. 1 times anything, I'll already tell you, is the same exact thing. No need to check. We want y by itself, so the plus 7 had to go across. It'll become minus 7. And I don't want 2y, I want 1y. So the reverse of multiplying by 2, I'm going to divide both sides by 2 to cancel this out. And once I have y by itself, which I do now because this cancels out, this is f inverse x. 5x minus 7 over 2. I didn't want I didn't want f inverse x. I wanted f inverse 9. So now that I have f inverse x, I could replace x with 9 in this new function that I created. So this is 5 by 9 minus 7 over 2. 9 5 is 45 minus 7 over 2, and is no coincidence. It works out to the same thing as above, because remember, when I stick in 9, I get 19 in the regular. So in the reverse, if the sticky 9, you're going to get 19 as well. Right, so let me look at the next functions question. Slightly different one with the arrow diagram. This is what they call arrow diagram. So they're just showing you what, when I stick in this answer here, what's it going to produce. So f at x, and again, that's the different notation they use. Both of these mean the exact same thing. So don't let this notation confuse you. Both of them mean the same thing, right? F such that x maps onto that is the same as this. So when I stick in my answer for x, it producing a f at x input, giving me output domain, giving me the range. So let me just double check some of the other answers. We don't know A. But when I stick in 0 in here, meaning x is 0, this is really 3 minus 2 times 0, which is 0, and it produced 3. Let me look at the next one. When x is 1, 3 minus 2 times 1, which is 2, 3 minus 2, 1. So that's how it works. So what I really need to figure out for this one is 3 minus 2 times minus 1. But when minus 2 times minus 1, what are we going to get? So you have to be careful with stuff like that. Minus 2 times minus 1, which is what this means. 2 by 1 is 2, yes, but the minus and the minus is going to give me a plus. So this is really 3 plus 2. So that answer is really 5. So that's what I'm going to get for that one. And again, that was what they was trying to make sure you know when the signs clash. Again, they want the inverse of that function. So again, the function is 3 minus 2x. So to get the inverse, I'm going to use y and x. Switch x and y, that's the key part there to switch. So x is equal to 3 minus 2y, and then I want to solve for that. So again, you have to pay attention. If I carry this to this side, minus 2y to this side, everything going to be positive. So I'm going to carry the minus 2y to this side. So I'm going to get positive 2y because it's easier to deal with positive 2y, and I'm going to carry the plus x to this side. So 3 minus x. I do both of them in one step. Minus 2y went across, and then I move across the x. So I have y by itself on this side, and x go across again to get 1y, multiplying by 2. I divide both sides by 2, and once I have that, that is f inverse x. So f inverse x is 3 minus x over 2. They just asked for f inverse x, so they need to work out anything. They want the composite function f squared x. Now f squared x really means f x. And we already know f at x is 3 minus 2x. From before, we know f at x is 3 minus 2x. So f of x means f at 3 minus 2x. So that means if it was a number, wherever I see this, I replace it with x. So instead of having 3 minus 2x, I'm going to replace x with whatever in the bracket, which is 3 minus 2x in this case. Then I just expand, you realizing the algebra coming into play here. So 3 minus 2 by 3 minus 6. Again, a minus and a minus is going to give me a plus 4x. So I'm really going to get 3 minus 6, which is minus 3 plus 4x. Or I could write the positive term first. So that's what f of x, so f squared x, is going to look like. And for the last part, again, as hard as it will come, is something like this. They want a composite function, f inverse minus 2. So we're going to work out f inverse minus 2 first. So I'm going to work out f inverse minus 2. I'm going to put it on this side here. So we already have a function for f inverse x. F inverse x we found out was 3 minus x over 2. That's what we work out up here. Alright, we worked that out in the first part. So if I want f inverse minus 2, I'm going to replace x with minus 2. So 3 minus minus 2, because I'm replacing x with minus 2. All over 2, you realize these two signs are going to clash. So I'm really getting 3 plus 2, 5 over 2. So that means this bracket here is really 5 over 2. So I have f, and in the bracket, 5 over 2. And if f function again is 3 minus 2x, but I'm going to replace x with 5 over 2. So I don't have x, I have 5 over 2. That's 2 times 5 over 2, or 2 or 1 times 5 over 2. The 2 is going to cancel, so I remain with 3 minus 5 after those 2's cancel. And 3 minus 5, the overall answer for that going to be minus 2. Again, a little more difficult, but you could still get some marks. I'm not asking that you get full marks on every question, but watch where you could get marks. Because sometimes it could be a little more complicated like this. This was a harder one, as hard as it normally comes. Sometimes it could be as simple as the first one we did with the f at 4 minus f at minus 4. But the goal is to try it and see how much marks you could get out of these questions.